Good evening. Today we are going to see the assignment number 8 of NPTEL. Now question 1 we have in this, what is the maximum allowable slenderness ratio of placing bars in built up columns? So now if we will go through the material, that is study material they have given. So in that one they have mentioned the slenderness ratio LE by R of the lacing bars. So here they have mentioned should not exceed 145. And they have mentioned there what is the maximum allowable slenderness ratio. So we have value that is 145. So option that we have, that is option is C. Then we have next, in sloping lacing system, the angle of inclination of lacing bar to the axis of the member should be in the range of. That also we have actually seen in IS also. So this angle that should not be less than 40 degree nor greater than 70 degree. So we have again option, that option is C. Then go to the third question. Battens provided for a compression member shall be designed to carry a transverse shear equal to. Now again they have given calculate transverse shear V equal to 0.025 P. Now they have written there in percentage. So what will be 0.025 into 100. And then 2 decimal we will shift to the right and we will get 2.5%. So 2.5%. So we have option, that is option A. Then we have next question, a laced column 10 meter long is carrying a factorial axial load 1000 kilonewton. The column is restrained in position but not in direction. That means both ends are pinned. Then they have given 2 ISMC 250. Then their properties are ZZR1 are placed back to back in a distance such that the slenderness ratio about both the direction becomes equal. The effective length of laced column is now 10 meter long. And then we have that will be restrained in position but not in direction. And for that we know when it is restrained in position not in direction, both ends are pinned. So it will be L effective equal to L. So that will be 10 meters. So we have, but for laced column, we know that value that is increased for by 5%, or for batten column, it will be by 10%. So L effective laced is 1.05. L effective we can write of column. Then we have 1 L effective equal to 1 into L, just I have mentioned here. Then we have 1 into L effective is L effective, that is of column. So we have 1 into 10,000 millimeters. And then we will get L effective less 1.05 into 10,000. And it will be 10,500 mm. So which is equal to 10.5 meters. And option we have, that is option B. So we have option B. Now go to question number 5. Which of them are the modes of failure of lattice compression member? So now here failure modes of lattice compression members. So now which are given distortion of this section. So you can see we have distortion of this section, that is a failure mode. Then given buckling of main component. So you can see buckling of main component is also a failure mode of lattice compression member. Then we have buckling of built up members, that is also failure mode. So we have answer, that is all the above are failure mode. So we have answer, that is D. Then go to sixth question. a lacing member of length 500 mm is attached to the column using weld. Now this is most important, using weld. Then find effective length of lacing member. So now we have these types of weld and effective length. So first is bolted and single lacing, double lacing, bolted at ends and intersection. Third is welded lacing, and that is given 0.7 times the distance between inner ends of the lengths of welds. So a lacing member of length 500 is given. So we will get this value. L effective is 0.7 L, not L effective. Then we have 0.7 into that is given 500. So it comes L effective 300 mm. So we have 300 mm means we have option is A. So A option. Then we have question 7. For end batten, the effective depth of batten should be more than. Now we have given these options. So here we have the effective depth of batten D shall be taken as the distance between end rivets or end welds. Now for end battens, so that is given D greater than A. And what is given A? So A is centroid distance of members. The centroid distance of members means we have option is A. That is the centroid distance of the member. Then we have next question. If C is the center to center distance of battens longitudinally, S is minimum transverse shear between the centroids of bolt group connecting the batten to the column member. Then all this V is transverse shear, N is number of planes. Then what shall be moment? So now this is given. Calculate moment at each connection as M is equal to VC upon 2N. So we have option, that is option is B. So M is VC upon 2N. So now we will stop here only. Remaining questions we will see in the next video. Thank you.